All right, this has got to be in focus. Oh my god, how am I so bad at this? Hello, welcome to another Science Monday. Elon Musk blew our minds this past week at the International Astronautical Congress held in Australia with his announcement and clarification of SpaceX's plans to get people to Mars and make us a multi-planet species. Crazy stuff. So, first of all, let's back it up a little bit and kind of set a baseline for how hard this is to do. There are three major things that make space travel so hard. It's cost, it's efficiency of rockets, and it's the weight of stuff that you want to get into space. So, first of all, use this little prop here. Pretend this is the Earth. This is what Earth looked like. I would definitely love to live on it. So, to get a rocket from the surface of the Earth to low Earth orbit, which is like here, maybe even lower, like the International Space Station, it's not like floating around in interstellar space. It's barely off of the Earth's surface and just orbiting like this. So to do that is like half of the cost of your fuel. I mean, it's insanely hard to get out of the gravity well that Earth has. And so Elon Musk has been trying to solve that problem since day one. The biggest thing, and stuff that most of you have probably seen, are the SpaceX first stages, taking a payload up into space and then turning around and coming right back down and landing. There's also a lot of videos of them screwing that up and awesome explosions on the drone ship at sea, so you should check that out. Anyway, three things: cost, efficiency, and weight. The cost of getting something to low Earth orbit before SpaceX came around was around 10 grand for 1 kilogram. That's real expensive. A 16-ounce bottle of water is like 2 kilograms. So, Jesus, that's 20 grand to get a bottle of water into space. Oh my God. SpaceX has gotten that number from 10 grand per kilogram down to about 4 with their Falcon 9 rocket. And that's a crazy savings. You're talking about 8 grand to get a bottle of water into orbit versus 20. And if you just keep going on that, you're saving billions of dollars over multiple launches to get things into space. Now, that's just the Falcon 9 rocket, which is the current rocket that they use to refuel the International Space Station and throw other people's satellites up into orbit. They've been launching a bunch of stuff, and it's pretty great. So anyway, Elon Musk revealed their BFR, which is their big effing rocket. I guess they don't have a better name for it right now. In comparison to the Falcon 9, which can take 15 tons total up into low Earth orbit, this BFR can take 150, 10 times the amount. The only thing that's ever come close to that is the Saturn V, that obviously took the Apollo missions to the moon. That thing could get 135 tons into orbit, but at a crazy cost, because that whole first stage and all those engines just plopped into the ocean, and it was a waste. No good. So anyway, cost-wise, they've got it down by reusing that first stage, which is a huge part of it. The other two things are the efficiency of the rockets, which is insane. Their Raptor engines are so cool. There's a thrust to weight ratio, which is very important, which is like how much thrust there is compared to how much weight you can get into space. So they put out a ton of thrust. And then the ISP, which is basically the efficiency of the engine measured in seconds when you've got the throttle all the way up to max and how long it can burn for. So anyway, their efficiency is insane. And I can't find detailed information on that, obviously, because SpaceX isn't just like, hey, check out our competitive advantage. But it's amazing what they're doing. I don't know what Musk is doing and what those engineers are doing, but those are smart people to be figuring these problems out. It's amazing. So cost, they're just slashing it, and it's just getting more efficient. The more launches they get paid to take up, the more money they have to put in research and development. It's awesome. The other thing is weight. the weight of the rocket itself, not just the payload sitting at the top of the rocket, but the weight of the rocket itself is a problem because metal is heavy. And so for this BFR, they've actually finally made a carbon fiber that can hold super duper cold liquid oxygen. So that's been the problem. You haven't been able to use carbon fiber in the past because it will just crack and then your fuel goes everywhere and your rocket blows up. But apparently they've got this deep cryo tank that can hold like 1,200 tons of liquid oxygen. And with that much weight, being saved, it's just that much more efficient and that much cheaper to get things into space. This first image shows you a whole bunch of rockets, and it is in order of how much payload they can handle. And you can see the BFR all the way on the right next to the Saturn V, and then on down from there. And then they reorganized this chart, which you can see here, and this is how efficient and cost-effective it is. So the BFR not only takes first place for amount you can get into space, but also first place for cost efficiency. And that's exactly what we need for a mission to Mars, which is going to be multiple launches over a long period of time. Now, getting to Mars is tricky. There's a certain window that happens about once every 2 years where we can launch from Earth to Mars, where our orbits kind of line up and we're the closest to each other, sort of. And then it takes around, 4 to 6 months to get to Mars after that. But so we can only launch really once every 2 years. But the BFR is looking to carry like 100 people at a time, and kind of comfortably so. This thing that he outlined has like crew cabins and entertainment areas and a lounge. It's not like you're just strapped into your seat and you're sitting there for the 6-month ride all the way to Mars. It's spacious, apparently. We'll see how it looks when it's actually built. But this guy wants to get us there by 2022. That's right, 2022. Even if it's 10 years away, I'm going to get to see this in my lifetime, and I'm super stoked. And I think the most exciting thing about all of this is that Elon Musk is doing this because it's cool. He wants to inspire people. He wants to remind us that there's something bigger than just our own bullshit here on Earth, and we should achieve and aspire to do great things with our lives. And it's really amazing. In the description section below, I'll link a couple of the videos, but one of them outlines the entire process from loading up passengers to landing them on Mars. And the first time I watched it, I got emotional. It's really inspiring. I love the vision, and I love the fact that he has the ability to actually make real change and huge steps forward in this. So if you didn't know, now you know. It's pretty awesome. If you like the video, click subscribe below, and we'll see you next Monday.